Okay, in this video we're going to keep going with section P-5, more factoring polynomials. We're going to do some different ones here. We're going to start with trinomials that have a leading factor greater than 1. We'll do the special case difference of squares, perfect square trinomials, and the sum or difference of two cubes. So let's the fun begin here. Example 5, we got this polynomial now, 8x squared. That's different. We usually have a 1 there. That makes those other problems easier, so that 8 is a new twist on this. And then we have minus 10x and a minus 3. We are going to need the factors of 8, and that would just be 1 times 8 and 2 times 4. And we're going to need the factors of that 3 at the end. And that's good because it's prime. It's only 1 and 3. So I know I'm going to come up with a couple of binomials here. And the leading term will each have an x in it, because I know x times x gives us the x squared. But I don't know what number go in front of the x's. Is it 8 and 1 or 1 and 8? 2 and 4 or 4 and 2? The 3 is prime. That's good. We can just stick that in here anywhere, 3 and 1. And notice I didn't put any signs in just yet. Okay, let's start playing around here. A lot of these you just do a little guessing and checking. When I factor my leading coefficient, I usually save these for last. That's usually not going to be the answer, especially in this case with something as big as an 8 in there. But let's try one out real quick. If I put the 8 here and the 1 here, my outer terms would multiply to 24x, and my inner terms would multiply to 1x. And there's no way I can add or subtract those to get the negative 10. So I know it's not 8 and 1. If I reverse it and do 1 and 8, here the outers would multiply to 3x, and the inners would multiply to 8x. And if I add or subtract those in any direction, I'm still not going to get to 10. So it's probably not 1 and 8. Let's see, how about the 2 and the 4? Well, let's just try off by starting with the 2 here and the 4 here. So if I multiply my outers, I get the 6x. And if I multiply my inners, I get a 4x. Ooh. Now that does get me to the 10x, but these would have to both be positive 4x and a positive 6x. That would make these both positives. And we know that's not the case because we have a minus here and a minus in the middle. Oh, now what if we make those both minuses, though? X, X. Yeah. If I make this a minus and this a minus, yeah, those would add up to negative 10 then. So if I do my first times first, that's my 8x squared. My last times last, ooh, but if I do it that way, minus 1 and minus 3 multiplied would be positive 3. So that looks like it is not the case. Let's switch the 2 and the 4 then. Let's put the 4 first and then the 2. Okay, now if I do my outers, I get 3 times 4 is 12. That'd be a 12x. And then 1 times 2 is 2x. Aha. Can I combine those somehow to get to negative 10? Well, to get to negative 10, this would be a minus 12 and a positive 2. So when we multiply these outers, we want that to be a negative number. So the negative would go here with the 2x and the 3. And then that means the positive would go between the 4x and the 1. And these you always want to just do a last minute double check just to make sure. 4x times 2x is 8x squared. Positive 1 times negative 3 is negative 3. Our outers multiply to negative 12x. Our inners multiply to positive 2x. And if you add those together, you do get the middle term, minus 10. So the better you can factor and FOIL stuff out to check your answers, the easier these ones go when your leading coefficient is greater than a 1. Okay, now this is a special case. It's a shortcut. If you recognize that you can use it, it will save you time. You can always just do it, the old way if you don't recognize that it is a shortcut scenario. But if you got two numbers, A and B, they're real numbers, variables or algebraic expressions, then we can do this. If you have one perfect squared minus another perfect squared, it breaks down into a sum and a difference, a plus and a minus. The two terms added, a plus b, times the two terms subtracted, a minus b. And again, this only works for difference of squares. A squared minus b squared. This never works for the sum of squares. It will never factor down like that. So when I look at the first one, I do see x squared. That's a perfect squared. And I see 4. That is 2 squared. And we can write it like this if we want. That is x quantity squared minus 2 quantity squared. Those are the two factors that we're interested in. Because this is a difference of squares, it will turn into a sum of x plus 2 and a difference of x minus 2. Because when we FOIL it out, the outers will be a minus 2x and the inners will be a plus 2x, and those will always cancel out, and we'll have no x term in our final answer. And this one wouldn't be bad to do, sort of the old way. We could say, how do we get x squared? Well, that's got to be x and x. What are the factors of 4? It'd either be 4 or 1 or 2 and 2, and we want them to add up to a 0 in the middle, because we could tuck in there a 0 x to the first power. So what two numbers would add up to 0? A positive 2 and a negative 2. There we are. Letter B is easier to do with the shortcut, and it's something, these numbers should jump out at you as perfect squares. 81, that is 9. 7, the square root of 49 would be 7, or 7 squared would be 49, so those are the numbers we're interested in. And we also have that x squared, so that would be 9x quantity squared and 7 squared. So those are our two factors. We will have a sum of them, 9x plus 7, and a difference of them, 9x minus 7. The same two terms with differing signs between them, a sum and a difference. Again, if you FOIL here, you'd get a negative 63x, and in the middle, a positive 63x. And that's what gives us no middle term back in the original problem. So always be on the lookout for those perfect squares. Now here's another one. We got x to the 4th and 81. Well, 81, of course, that's 9 squared. X to the 4th. What do you square to get x to the 4th? Well, that would be an x squared. Oop, that's a terrible squared. So we've identified our factors, and we know we're going to have a sum, an x squared plus 9. And a difference, x squared minus 9. And is that the end of the problem? No, it is not. Because again, here we have a difference of squares. I'm going to bring down this x squared plus 9. There's no way we can factor that. But x squared minus 9 is also a sum and a difference. An x plus 3 and an x minus 3. So that was a repeated factorization. Factored it once, and we were left again with a difference of squares, and we factored that difference of squares yet again. Okay, now there's another special case, a perfect square trinomial. A perfect square trinomial is going to be, you're going to have your ax squared plus bx plus c. And when you factor it down, you can turn it into a binomial quantity squared, like a plus b or a minus b. But it'll be a repeated factor, a plus b times a plus b, and we can just shorten that up and write a plus b quantity squared. Again, we're training our eyes and our brains to look for perfect squares, and that also applies here. In the first one, I see in front of that x squared, of course, as an implied 1, so this is a perfect square. And this last number 9 is also a perfect square. So what we can do is try to make a binomial and then test the middle term. And the way I like to do these is whatever this first term is, I'm going to bring it down and square root it. The square root of x squared is x. Whatever the first sign is here, that also comes down. This is also going to be a plus. The last term 9, square root it, bring it down, we have a 3. So we think we might have x plus 3 quantity squared. We want to double check and make sure this middle term works. The middle term is the first thing, x, times the second thing, 3, times 2. If we multiply here, we get 6x. Is that our middle term? Yes, it is. So we checked it out, and it did, in fact, work. And also on this one, because our leading coefficient is just a 1, you could also, if you didn't recognize that you might be able to use the perfect squared trinomial shortcut, you could say, I want to break this up. How do I get x squared? Well, it's got to be x and x. What are the factors of 9, 9 and 1, or 3 and 3? What of those add up to 6? Well, it would have to be a plus 3 and a plus 3. And then when we have a repeated factor, of course, we can write that as the quantity squared. Now, because we have this huge leading coefficient here, doing it that way might be a little harder. But again, we're looking for perfect squares. I see a 25. I see a 36. Those both jump out as perfect squares. So let's bring them down and square root them. The square root of 25 is 5. The square root of x squared is x. Bring down this sign, whatever it is. This case, it's a minus. Bring down the 36 and square root it. Square root of 36 is 6. Now we check the middle term. 2 times the first thing times the second thing. Well, 2 times 5 is 10. 10 times 6 is 60. 60 x's. Is that our middle term? Yes, it is. So our binomial is 5 minus 6, and that is quantity squared. And let's see what's going on here in example 10. Now we are to the sum and difference of cubes. Notice when we did squares, we could only do the difference of two squares. Now we can do the sum or the difference of two cubes. And this is pretty similar to what we already did. There's a nice little pattern to it. There's a nice little pattern to figuring these out. So first we have to recognize that we do in fact have a sum or difference of cubes. And when I look at example 10, I see an x to the third, and that is x cubed. Plus, can we rewrite 8 as something cubed? Well, 2 to the third is equal to 8. So there are the two factors that we're interested in. And when you're doing a sum or difference of cubes, it's always going to break down into a binomial multiplied by a trinomial. So I got a smaller set of parentheses here, and then I made a little bit bigger set. The binomial is very easy to create. We're just going to bring down this x. We're going to bring down the sign plus, and we're going to bring down the 2. From this, we create the trinomial. Whatever our leading term is, we're going to bring it over here, and we're going to square it. So x squared is x squared. The last term, we bring it over, and we square it. 2 squared is equal to 4. Whatever our sign is here in the binomial, here we have a plus, that's always going to flip. And now this in our trinomial is a minus. So we want to flip that first sign. The middle term is just the first thing times the second thing. 2 times x is 2x. And the last sign here is always, always, always positive. Always plus. So let me get rid of some of this distracting lines and stuff around it. There is our factorization of the sum of two cubes. X cubed plus 8 breaks down into this binomial times this trinomial. And if you don't believe me, FOIL it out and collect your like terms, and you should get right back to where we started. Okay, let's try it for this one. So 64x cubed is something cubed minus, and 125 is something cubed. Well, 8 is, or the cube root of 64 is 4, and the cube root of x cubed is x. So here we have a 4x, and that's quantity cubed. And then 125, well, that's 5 cubed. So that is going to help us create our binomial. And let me just move it over here. I like to draw it right underneath. Here we're going to have a binomial, and we're going to multiply that by a trinomial. The binomial, you bring down the 4x, and you bring down the minus sign, and you bring down the 5. Now here, we have to create the trinomial. So remember, whatever the first term is, we bring it over and square it. And remember, that would be quantity squared. 4x times 4x is 16x squared. Whatever sign we have here in the binomial, we flip. So we're going to go from a minus to a plus. Our middle term is the first thing times the second thing. 5 times 4x is 20x. And then the last sign is always positive. And we bring this final term over and square it. 5 squared is 25. So again, we have our binomial times a trinomial. And just in case you missed the squaring stuff, you can always do a quick check like this. Just do the first term times the first term. 4x times 16x squared is 64x cubed. 5 times 25 is 125. So just in case you brought over this as a 5 and not a 5 squared, you'd catch your mistake there. Or if you just brought over this as a 4x squared, you'd catch your mistake there. Oh, and that's it for me. Some practice problems for you. Pause the video, try these out, fire it back up, and see if you got the right answers. All right, let's try this first one out. This could get a little nasty. Our factors of 6 are 1 and 6 and 2 and 3. And we got quite a few factors of 12. 1 and 12, 2 and 6, 3 and 4. Ooh, so this one could, take a little trial and error here. Again, I shy away from the 1 and the 6. I might want to try a 2x and an x. And I'm going to go to the middle here and try this 2 and 6 and see how close we get. Sometimes you stumble right into it. Other times it takes a little work. So I set it up so I know, ooh, what did I miss there? I forgot my 3. Why didn't you tell me? There should be a 3 in there, right? Yes. So I was doing, I want all the color to match there. So let's make that into, there we go. So I got my 2 and 3. 2x and 3x will give me the 6x squared. The 2 and the 6 will give me the 12. And let's not worry about signs yet. If I check my outers, I'll get a 12x. And if I check my inners, I get a 6x. Pretty close. If I were to add those, I would get 18. If I made them both negative, I'd get to negative 18. So we're kind of close. We might just want to switch one thing, and see what happens. So let's see, we did 2 and 6. Let's try 6 and 2. So I'm going to put the 2 over here and the 6 over here, and I deleted my 3. Why do I keep doing that? There we go. Okay, if we do it this way, our outers would be 4x, and our inners would be 18. If we add them, we get 22. If we subtract them, we get 14. So that's not the way to go. Okay, so maybe 6 and 2 were not the problem, or are the problem. Maybe it's the 2 and the 3, we don't know. Next up, let's try 3 and 4. If we do 3 and 4 this way. Outers, we get 2 times 4 is 8x. And inners, I like this. 3 times 3 is 9x. If we add those, we get 17. We want to get to negative 17, so we're going to make them both minuses. And let's see if that works or is the solution to the problem. So first times first, 2x and 3x is 6x squared. The minus 3 and the minus 4 multiply to positive 12, which we have right here. And our outers are minus 8, and our inners are minus 9, and those are both x's, and that adds up to the minus 17. So there's our factorization. That was a tricky one. Took a little work. Okay, 30. 8x squared plus 33x plus 4. Okay, the factors of 8. 1 and 8, 2 and 4. Factors of 4. 1 and 4, 2 and 2. So it's all a guessing game. The middle term, 33, that's a pretty big one. I might want to try here, to get to 33, I'm looking at this 8 times 4. That might be the way to go. So here, I'm going to do an 8x times an x. And the factors, I might lean toward the 1 and the 4 this time. Remember, whatever goes over here gets multiplied by the 8. So if I put the 4 over here, that's 4 times 8. That's going to get me real close to 33. So maybe it's the 1 goes in here. And this, the signs aren't bad because it's a positive and a positive. We know everything is positive. So 8x times x is 8x squared. 1 and 4 gives us the 4. Let's check the outers. 8x times 4 is 32x. And the inners, 1 times x is x. If we add those up, we do get to the 33. Boom, got it right off the bat. So these can be tricky, but again, a little forward thinking sometimes help. That middle term being a great big old 33, I look over here and I see the 8 times 4 is the only way to really get close to that. And finally, 9x squared minus 6x plus 1. And the factors of 9, 1 and 9, 3 and 3. Factors of 1, it's got to be 1 and 1. So this one might need a little guessing and check, but we should be okay. We know this is a 1 and a 1. If we have a negative in the middle and a positive here, that means two negative things add up to a negative. Two negative things multiply to a positive. So this will be minus and minus. So we just got to figure out, is it a 1 and a 9, each with an x after them, or 3 and 3? Because the middle term's a 6, I'm thinking 3x and 3x. Ooh, and I see how we should have approached this problem from the get-go. Aha. Let's see, our outers would be a minus 3x, and our inners would be another minus 3x, and those add up to minus 6x. So there's our factorization, 3x minus 1 and 3x minus 1, which we can write as 3x minus 1 squared. Okay, now that I've seen that it was a more of a perfect squared binomial problem, this 9x squared, if I square root the 9, I get a 3. The square root of x squared is x. The square root of 1 is 1. Bring down the middle sign, and then this would possibly be our binomial squared. We check our middle terms. 2 times the first thing, 3x, times the second thing, 1. Well, if we multiply here, we do get the 6x in the middle. So that is it. I didn't even recognize the type of problem, but again, you can solve these multiple ways. Now here they're telling us difference of squares. X squared minus 144. Well, the square root of x squared is x. The square root of 144 is 12. So those are the two numbers or factors we're interested in, x and 12. So we're going to have a sum, x plus 12, and a difference, x minus 12, and there's our solution. 42, same thing. I see 64x squared. Well, that's an 8x quantity squared, and the square root of 81 is 9. So our two factors are a sum and a difference of these terms, 8x and 9. Oops. 8x plus 9, 8x minus 9. That was a bad parenthesis. There we go. Okay, the last one, a sum of cubes. Well, let's see what we got here. What do we cube to get x cubed? Well, it's got to be x. What do we cube to get 64? It's got to be a 4. So here we can create our binomial, x plus 4. And from the binomial, we can create the trinomial. Bring over the first term, square it. Flip the first sign, here it's a negative. The middle term are these two multiplied together. 4 times x is 4x. Last term is always a plus. We bring this term over and square it. 4 squared is 16. So there we go. The quantity x plus 4 times the quantity x squared minus 4x plus 16. If we were to multiply that out, we would get back to our sum of cubes. All right, let's see what the homework looks like here. Page 74, 25 to 28, and then 45, 46, 52, 54, 57, 63. Remember the odd ones, check them in the back of the book. The even ones right next to the odd ones are very, very similar. If you can do the odd number one, you know the even number one you should have a good handle on and get the correct answer. All righty, see you in the next video.